In this video, we're going to talk about evaluating combinations of functions. So in the previous two examples, we actually found functions such as f plus g of x. Now we're going to actually plug something in for x. So if you notice, in the examples that we're about to do, they all have a number here instead of x. If it's just an x there, then we're just asking you to find the function in terms of x. If I want to plug in a number, I'm going to put the 0 in there or the 3 in here, whatever it is that I'm asking you to plug in. Just like if I asked you, for example, to find f of 3, that means plug in 3. So that's exactly what we're doing here. So to find f plus g of 1, that's the same thing as saying find f of 1 and add it to g of 1. So if I take f of 1, that means I'm going to plug 1 into my f function. That's going to give me 6. And if I take 1 and plug it into my g function, that's going to give me a 1. And so when I add that together, I get 7. So f plus g of 1 is 7. Now, let's find f minus g of negative 2. That's the same thing as saying f of negative 2, and I want to subtract g of negative 2. So, if I find f of negative 2, I'm going to take negative 2 and plug it into my f function. So that's going to give me a 5 times a negative 2, which is a negative 10. And then a plus 1 gives me a negative 9. And then I'm going to subtract whatever I get when I plug in negative 2 into my g function. If I plug negative 2 into g, that gives me 3 times negative 2 is a negative 6. And then a negative 6 minus a 2 is a minus 8. So that gives me a negative 9 minus a negative 8, which is a plus 8, which gives me my final answer is a negative 1. So f minus g of negative 2 is negative 1. Now we're going to do f times g of 0. So I want to take f of 0 and multiply it by g of 0. So f of 0 is 1. If I plug in 0 for f, I get 1, times, now I'm going to find g of 0. G of 0 is going to be a negative 2, so my final answer is going to be negative 2. So f times g of 0 is negative 2. Okay, last example for this, f divided by g of 3 means I'm going to find f of 3 and divided by g of 3. F of 3 means I'm going to take 3 and plug it into my f function, so that's going to give me a 16. And g of 3 means I'm going to take 3 and plug it into my g function, which is a 9 minus 2, which is a 7. So this is my f divided by g of 3. Okay. Next example, example 2, same thing, we want to find f plus g of 2. So I want to find f of 2 and add it to g of 2. F of 2 would be 1/5. And g of 2 would be the square root of 2. Okay, let's do f minus g of negative 1 now. I'm going to find f of negative 1 and subtract g of negative 1. Well, f of negative 1 would give me 1/2. And when I plug in negative 1 into g, I get minus the square root of negative 1. I can't do that using real numbers. So for this example, I would write does not exist or undefined. And remember, in the previous example up above, when we found the domain for this, -1 was not in that domain, which is why this isn't working. Okay, next example, f times g of 0. This means I'm going to find f of 0 and multiply it by g of 0. F of 0 is 1/3. G of 0 is 0. So when I multiply them, I just get 0. Last example, f over g of 4 means I'm going to take f of 4 and divide by g of 4. F of 4 is 1/7. G of 4 is 2. And when I divide 1/7 divided by 2, that's going to give me 1/14. So f of g, I said that wrong. So f divided by g of 4 is 1/14. That's a mouthful. Okay, for example 3, we're doing the same thing that we did before in the previous two examples when we evaluate, but in those two examples, we were given the function as an equation. In example 3, we're given the function as a table. So although we're completing the same task of evaluating, we're just using a different representation of the function. We're using a table instead. So if I ask you to find f plus g of 6, that's f of 6 plus g of 6. So if you look, the table that's in this greenish color is my f, and the table that's in this yellow color is my g. So if I want to find f of 6, I need to look at my table that's the greenish color and look, well, when x is 6, f of x is 30. So f of 6 is 30. Now I want to do the same thing with g of 6, but now I'm looking at the table that's the yellow color because we're looking at our g function. When x is 6, g of x is -14. So g of 6 is -14. When I add those together, I get 16. So f plus g of 6 is 16. Now let's do the same thing, but with f minus g of 8. I'm going to find f of 8, which is 26, and g of 8, which is -22, and I'm going to subtract. I'm subtracting a -22, so that's going to give me a 26 plus 22, which is going to give me a positive 48. Now we have f times g of 2. So that means I'm going to find f of 2, which is 23. And I'm going to find g of 2, which is 28. And I'm going to multiply those together. And I am going to get 616. Actually, I'm sorry, 644. I put that in wrong on my calculator. Okay, last example, f divided by g of 4. So that means I'm going to find f of 4, which is 16, and g of 4, which is 32, and I'm going to divide them, which would give me 1/2. Okay. For example 4, again, we're evaluating the combination of functions, but now instead of using an equation or a table, which are the two examples that we did previously, we've already used tables and equations. Now we're looking at it in graph form. So I want to find f plus g of negative 2. So the graph on the left is labeled as f of x, and the graph on the right is labeled as g of x. So when I'm looking for a value for f, I want to look on the left. When I'm looking for a value of g, I want to look at the graph on the right. So I need to find f of negative 2. So I'm going to look at the graph on the left, and if I look at negative 2 and I come up here, f of negative 2 would be 1. Now I got to find g of negative 2. So now I'm going to look at my graph on the right for g and look at negative 2, and my answer for that coincidentally is also 1. So when I add those together, I get 2. F minus g of 4. So I'm going to find f of 4. So if I look at my f function on the left, and I look at x equals 4, my f of 4 would be negative 3, and I want to subtract whatever I get when I find g of 4. So g of 4, when I look at the graph on the right, g of 4 is at positive 4. So I have a negative 3, and I'm subtracting 4, so that's going to give me a negative 7. Now let's do f times g of negative 4. So for f, I need to find f of negative 4. If I look at the graph on the left at f, negative 4 would give me a value of 3. And I want to multiply that by g of negative 4. G of negative 4, if I come across to negative 4 and I come down, that gives me a negative 4. So my final answer would be negative 12. F divided by g of 2 is equal to f of 2, which is 0, and g of 2, which would be negative 3. And when I take 0 divided by negative 3, that gives me 0. So we've talked about evaluating combinations of functions by equations, by tables, and now by graphs. So you should be able to do it in any representation now.